Hello everyone. So in this video, we will talk about the prime factorizations of numbers for the mathematics 10 course. Before we begin, we need some prior knowledge. You need to understand what the prime numbers are. What are some prime numbers that you know of? Well, I think of 2, 3, 5, 7, 11, and so on. We also need to know what the factors of a number is. For example, what are the factors of the number 12? Well, I can think of 1, 2, 3, 4, 6, and 12. After this video, you'll be able to learn about finding the prime factors of numbers and use them to find the greatest common factor and the lowest common multiple of multiple numbers. Let's try the first example question. Find the prime factorization of 48. Well, in order to find the prime factorization of 48, we first need to start by dividing 48 by prime numbers. So the first thing I'm going to use is I'm going to use a factor tree. And I'm going to divide it by the first prime number that I can think of, which is 2. Well, first, let's ask the question. Is 48 divisible by 2? Well, it is, because 48 is an even number. So if I do 48 divided by 2, that's going to be 24. And then I repeat the process. 24 can be divided by 2 once again. 24 divided by 2 is 12. And once again, 12 is divisible by 2. So let's divide by 2. 12 divided by 2 is 6. And of course, finally, 6 is divisible by 2, which makes it 3. A 3 is a prime number, which means that my job is completed. I have completely prime factorized 48. Let's write down our finding. 48 is equal to 2 times 2 times 2 times 2 times 3. You can leave your answer like this, or you can shorten it by counting the number of times that 2 has appeared. Well, I say that 2 has appeared 4 times. 2 is multiplied 4 times, which means we can write it as 48 is equal to 2 to the power of 4 times 3 to the power of 1. 1, you can omit it if you want. Let's annotate our process. To prime factorize, we find the smallest prime number. That divides, or that is a factor, which was obviously 2. We always want to start with 2, the smallest prime number. So it's 2. If it doesn't work, we will go with 3. If it doesn't work, we go with 5. If it doesn't work, we go with 7, and so on. So divide 48 by 2. And we want to write 2 and the quotient, which is 24, as a factor tree. And then after we're done, we write that as represent product of prime factors. So that's how we prime factorize a number. Now let's move on to the second example question. Find the greatest common factor and the least common multiple of 18 and 24. For these problems, we're first going to start off by prime factorizing each of the numbers. So let's prime factorize 18 and 24 separately. First off, 18 is divisible by the smallest prime number 2. It's divided by 2. 18 divided by 2 is 9. Well, 9 is not divisible by 2 anymore. So let's move on to the second smallest prime number, which is 3. Luckily, 9 is divisible by 3. 9 divided by 3 is 3. And therefore, we have our prime factorization of 18. So we know that 18 is equal to 2 times 3 times 3. Let's do the same thing for 24. 24 is divisible by 2. 24 divided by 2 is 12. And 12 is also divisible by 2. 12 divided by 2 is 6. And 6 divided by 2 is 3. And there you go. We have prime factorized 24 as well. So 24 is equal to 2 times 2 times 2 times 3. So now that I've completely prime factorized each number, let's first find the GCF, the greatest common factor. To find the GCF, we want to find the common factors. So every time I see a common factor for 18 and 24, I'm simply going to underline them. Well, I see a 2 and 2. They're common, so let's underline them. I also see that 3 appear in both, so let's underline them. Well, now 18 has 3 left, and 24 has 2 and 2 left. At this point, they don't have any more common factors. So I think that's the greatest common factor that we've found. Let's collect the common factors that we have found. So that's 2 times 3, the underlined ones. Therefore, the greatest common factor is equal to 6. Now let's find the least common multiple. To find the least common multiple, we're going to use the greatest common factor, and we're going to count all the extra ones that were not included in the greatest common factor. So let's do that. Well, first we have the greatest common factor, which is 6, times the leftovers, the 3 and a 2 and a 2. So I think if we do 6 times 3 times 2 times 2, we'll be able to find the least common multiple, which is 72. So that's how we find the greatest common factor and the least common multiple. Let's annotate our work. First, find prime factorization of both numbers. And then we want to underline common factors. To find GCF. And after we find the GCF, we find combine other leftovers with GCF to find LCM, the lowest common multiple. The names are a bit counterintuitive. The greatest common factor is always going to be less than or equal to any of the numbers, and the least common multiple is always going to be greater than any other numbers, greater than or equal to any other numbers. Let's recap the vocabulary and the formula that we've learned today. First, a factor. A factor is a number that divides another number completely without many remainders. And the prime number is a whole number that is only divisible by 1 and itself. Prime factorization is a process where we factorize a given number into a product of prime numbers. And the greatest common factor, as we said, is we find the greatest common factor of multiple numbers. How we do that is we find the prime factorization and we collect the common ones that we found. And of course, the least common multiple is after we find the greatest common factor, we include all the leftover ones that we have not included, and that is going to be the least common multiple of multiple numbers. Thank you for tuning in for today, and I'll see you in the next video.